All right, this is our very last science chapter of the year, so good job. This one's going to be kind of long because there's a lot of information put into one, like I've been saying every time. So let's get started. We're talking about the solar system, stars, and the universe. So, first of all, when back in the 1600s, Galileo and other scientists thought that space was really interesting and they wanted to learn more about it. So to do that, they decided that they were going to build some helpers. And so they created the very first telescopes. And here are some different examples of telescopes. The first one, this one right here, is the telescope that Galileo used. Now, it's basically just an optical telescope, which kind of magnifies the stars above. Galileo used it to see that there were moons revolving around Jupiter. He found the rings around Saturn and all kinds of different things. Now, you guys might have optical telescopes at your own house. You might not. You might have tried a friend's out. They're pretty cool, but they basically just use lenses. Now, telescopes in space, like this one, is an example of how we get pictures of our Earth or of different types of stars, of supernovas, different things like that. And the Hubble Space Telescope is probably the most famous example of one that has been orbiting around the Earth. That one was launched in 1990. Now, this one right here is a radio telescope, and they use radio waves to figure out what objects are in space. Now, let's look at the solar system. The solar system is something that you have been learning about forever, and you should know that there are the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now, the first 4 are the rock planets. They're a lot smaller and closer to the sun. Now, they're primarily made out of rock and different things like that. They do have some gases and stuff, like the gases that come from volcanic activity and stuff like that. But for the most part, they're just simply rocks. Now, the outer layer would be Jupiter, Saturn, Uranus, and Neptune, and those are the gas giants. They're primarily made out of gas, although they do have rocks as well. Now, between those is the asteroid belt. And if you can see that right between Mars and Jupiter, that would be where the asteroids orbit around the sun. And the asteroids can be tiny little rocks, and they can be absolutely massive. Now let's look a little bit into our interesting facts about our solar system. Let's look at Jupiter first. Jupiter has this storm spot, and this storm spot has been going for over 400 years. So that's kind of interesting. And the wind speeds are extremely fast, 270 miles per hour. And it is about 2 times the size of Earth. So that one little spot is more than 2 Earths put together. Saturn has rings made out of ice and rocks. And basically, it's comets, asteroids, and moons that have broken off and orbited around the Saturn's planet through gravity. Now, later on, scientists have found out that Jupiter, Uranus, and Neptune also have rings around them. So Saturn is not the only one. Venus is filled with violent volcanic activity, and they have long rivers of flowing lava throughout that planet. And then, of course, Mars is probably the closest to us. It is filled with volcanic boulders that some scientists theorize that there is water on Mars. So that's something that scientists have really been looking into lately. Now, we have our moon, but there's also a whole bunch of other moons. Jupiter's moon, Ganymede, is the largest moon. So here's our moon, there's Jupiter's moon. Now, the rest of them are a little bit smaller, and they're made out of different things, but for the most part, a moon is basically a natural object that orbits a planet. A moon could also be considered a satellite. A satellite is an object in space that circles around an object. So we are satellites to the sun because we orbit around the sun. Now, Earth has 1 moon, Mars has 2, Jupiter has 60, Mercury and Venus have none. Saturn has 45, Uranus has 27, and Neptune has 13. Now, just because we have these numbers doesn't mean that they can't change, and doesn't mean that that's the actual number, because scientists are always discovering new things. Now, the one thing that is important is a long time ago when I was in school, Pluto was considered the ninth planet, and throughout my schooling, Pluto was classified as not a planet no longer, a dwarf planet. And this is kind of a good reason why. So here's the size of Pluto, and here's the size of our moon. So it is extremely small compared to the rest of the planets, especially being on the other side of the gas giants. And moons are filled with craters, and these are basically holes where the smaller objects have hit them. Now, Ganymede is filled with craters, but those craters aren't actually holes. They're kind of filled up, and that's because there's a flowing ice that goes through Ganymede. So kind of interesting. Now let's talk comets, asteroids, and meteors. A comet is frozen gas and ice and dust and rock. And the core will warm up. The tail has ice or gas. There's two different types of tails. And a comet basically orbits around the sun. The tail will always point away from the sun. So very cool. An asteroid is a rock that revolves around the sun. And that's part of the asteroid belt. So this picture would be an asteroid. And this would be a comet. And then the last one over here would be meteors. Now a meteor in space would be called a meteoroid. If the meteoroid goes through Earth's atmosphere, it becomes a meteor. And then, of course, if it hits the ground, so if it actually strikes Earth, it would be called a meteorite. So just some vocabulary. Now let's talk about stars. Stars are one of my favorite things. They're so interesting. So star is basically created when a bunch of matter comes together, and that matter radiates energy with light or heat, different things like that. Now they all start off as a nebula, and it could be all kinds of different nebulas, but the nebula is basically how every single kind of life cycle of a star starts. And then they have different cycles. So if it's like a really powerful nebula and it might contract a lot of heat, then it will become a massive star. Where our nebula, our sun, was created by just a normal stellar nebula. Now that nebula has dust and gas, and that gas is mostly hydrogen, and that hydrogen will gradually heat up. And once it gets super hot, it will create helium. And that helium and that hydrogen will continue to expand and create basically this average star, so what our sun is right now. And then eventually that hydrogen will expand and it'll get bigger and bigger and bigger. But as it expands, it cools off. And so it basically turns into a red giant. It turns into this dark red color. After that, the temperature really cools down and the helium pretty much disappears. It's gone. And at that point, it turns into a white dwarf. And before that, it could turn into a planetary nebula, which is where we get our solar system. Now, if you have a really large stellar nebula, it turns into a massive star. And then it turns into a red supergiant. And when that red supergiant, basically, when it gets really, really hot and it explodes, and that explosion turns into a supernova. And that supernova could become a neutron star or a black hole. And black holes are extremely powerful. They have so much gravity that absolutely nothing can escape a black hole. They're nothing, not even light or sound or anything. So the life cycle of our sun is this guy on the top. The life cycle of some of the other suns in the the suns in the universe could be a massive star, a red supergiant. Now, there are billions and billions of stars in our universe, so most of them are average stars. Now, a long time ago, the Greeks, the Chinese, all kinds of different civilizations made stories out of the stars. So basically, when they laid there and looked at the night sky, they decided that they could see different objects. So they could see the Big Dipper, the Little Dipper. They could see Orion and his belt, and the W, and all kinds of different objects or people or animals that they saw that they could see in the stars. And these are called constellations. So usually they would make stories, and these characters would be part of the stories. And then they would show the kids, and the kids would find those characters, and then they would pass it on from generation to generation. So the story of Orion is actually really old, and it comes from Greek, from the hero Hercules. Now, the Chinese also made some different constellations, but we don't really focus on those that much. We usually hear the Greek and the Roman stars that they saw. Now, stars are actually so far away from us that we consider them being light years. Now, for example, one star, the next closest star to Earth, is 24,800,000,000,000 miles away from us. So we just make them light years now. So, yeah. Now let's talk about galaxies. Galaxies are basically a batch of stars made to get together. It's like a huge collection of stars. The universe may have more than 100 billion galaxies. Now it's galaxies. That means that there's billions of stars in each galaxy. For example, the Milky Way that we live in contains more than 200 billion stars. So let's talk about the different galaxies, how they form. We are a spiral galaxy. This is what the Milky Way would look like from really far away. And we're just hanging out over on one of these outer wings somewhere. Not outer arms, sorry. Now, there's other types of galaxies, like an irregular galaxy that doesn't really have a shape. A barred spiral, so it kind of has an egg shape in the middle, and then it has some arms coming out. And these ones are a little bit less familiar with, but the top three are pretty common. There can be globular clusters that are like a sphere, and they hold 100,000 or more stars, and just all kinds of different galaxies. Now, how did our universe form? Well, some scientists believe that our universe was formed from a big bang. So, if you think of our universe like water, basically, the Big Bang was like a stone getting thrown into the water, and that impact of energy caused ripples to form in the water, and the ripples just kept going and going and going and going. That's basically what scientists assume happened to our universe. So basically, there was some kind of boom, and now the universe is continuing to expand through ripples. So, yeah, according to our textbook, the universe is still expanding. So, kind of interesting. Now, you may believe something differently. This is just from what science has theorized. And yeah, that's basically the solar system, galaxies, and stuff in a nutshell.